Hello and welcome back to the Strange Water Podcast. Thank you for tuning in for our 26th episode. We've got something very special for you today. Let's start with a fact. One of the most important reasons that Ethereum is so secure is because the EVM is not connected to the outside world. By limiting the ability of smart contracts to reach out into the open internet, massive swaths of digital vulnerabilities are rendered completely moot. But this security comes at a cost. Because smart contracts are bound by the relatively tiny confines of the EVM, they are severely limited. Forget about computation limits, gas costs, or any of the resource-based calculations that we all make today. Without access to outside data, functions, and systems in the real world, the only applications that you can build within the EVM are self-referential and, quite frankly, boring. So here's the dilemma of early Ethereum. How can we connect Ethereum to the outside world without breaching the sacred protection of the EVM? By today, the answer is well understood. We call it oracles. Oracles are services that take real-world data and send a copy into the EVM, storing it in a smart contract. Once there, every other citizen of the EVM can refer to that data, or they can run the process in reverse and send a command to the smart contract, where the oracle is watching and can notice the command and process it off-chain. This paradigm effectively gives smart contracts access to the outside world, facilitated by messages relayed by oracles. Okay, so that's oracles at a super high level. Pretty easy to grasp, but the second it clicks, a million questions come up. For example, like who are these oracles, or how do we ensure that they're honest? But perhaps most interestingly, at least to me, is can this technology be used to connect two blockchains? And can they do it so strongly that we might not need to think about distinguishing between blockchains at all? Today, we have the perfect guest to answer all of these questions and more, ChainLinkGod. To most of you, CLG is well known for his sober, well-reasoned, and fierce advocacy of Chainlink and of Ethereum. For those of you who don't, pause this episode right now and go follow him on Twitter. Either way, this episode is jam-packed with everything from Chainlink's history, their latest product called Cross-Chain Interoperability Protocol, or CCIP, how ZK fits into the Chainlink roadmap, and so much more. One more thing before we begin. Please do not take financial advice from this or any podcast. Ethereum will change the world one day, but you can easily lose all of your money between now and then. Okay, time to start the show. ChainLinkGod, thank you so much for joining us for the Strange Water Podcast. Great to have you on.
Absolutely. Thanks for having me on.
Of course, man. So before we get started with like the meat and potatoes of this conversation with Chainlink and CCIP, I'm a big believer that the most important part of every conversation are the people in it. And so I'd love to start with just who are you, as much as possible, with somebody who has decided to remain anonymous. But who are you, and what brought you to this like crazy, weird, financialized part of the internet?
Yeah, so my name is ChainLinkGod. I'm a Chainlink community ambassador, or that's my pseudonym, at least a better way to put it. Just call me CLG, might be simpler. I try to help educate the community, the Chainlink community, about what oracles are and what Chainlink is developing and what use cases exist and how the ecosystem will evolve, as well as kind of talk about other interesting things I see in the crypto ecosystem, like tokenized assets and on-chain financial ecosystem, and basically whatever piques my interest I like to talk about effectively and write about and talk about. I originally got into crypto later part of 2017, early 2018, when that was like peak bull market mania, and I saw that people in like the gaming community were using GPUs to basically run this program on the computer and print money out of it, and I thought, oh, that's interesting. I know the gaming community was really pissed at crypto miners because they were buying up all the GPUs at the time, and so I ran this program, made like $3 a day. It's But it was more like the intellectual curiosity, like what is my computer even doing? Like why is these digital bits have economic value? Why can't I convert them to cash? And so I kind of fell down the crypto rabbit hole from that, from like a computer science distributed system type perspective, and I kind of dived into Bitcoin, learning, the monetary policy of Bitcoin, the immutability of the ledger, the transparency, what is blockchain trying to solve in the first place. Then I looked at like CoinMarketCap. I saw there were like these million tokens doing various things, and they were all on Ethereum. Like every single token was based on Ethereum. Like, okay, well, why is that? And then I dove into Ethereum and saw it was a smart contract platform with these immutable applications, and started to learn that blockchains are not just used for currencies, crypto native assets, but all of these applications as well. And then it kind of came to like the next question of like, how is a smart contract supposed to be useful if it doesn't know anything about the external world? If I have a contract about a mortgage or a house or something, how is it supposed to know where the house is, who owns it, what it's worth, what the condition is? And then that kind of from there stumbled into Chainlink. And this was like 2018, so like the team wasn't doing any marketing. It was just a white paper. It was just basically an idea, but it clicked and made such intuitive sense to me that like the combination of smart contracts and oracles basically means any digital agreement can be automated and operate in a much more trust minimized and verifiable manner, which to me just like once I learned about it, it just seems so obvious that this is the way the economy is going to work. It's the crypto ecosystem has definitely evolved, and I've learned a lot over time. But yeah, that's kind of like the initial roots of how I got into this crazy space we call crypto.
For sure. And so before we like get to you understanding that oracles are the big unlock and then falling into the chain link, like while we're still in these early days of CLG in crypto, can you just talk a little bit about what you understood crypto to be from first principles and from like your organic understanding of as an outsider coming in? I mean, for example, when you saw crypto, did you think, okay, this is just digital money and that makes sense to me and went from there? Or what were your first like understandings of what we're even trying to do here?
Yeah, so I didn't come into it initially from like purely an investment perspective. I mean, I was like literally just coming out of high school at the time, so I didn't really have that much disposable income. So it was much more about the tech, ironically there, but it was much more like learning if you want to have some type of system of agreements that doesn't operate using a trusted counterparty, how do you get everybody to agree with one another? How do you come to consensus? If you have a ledger of transactions, you can trust a bank to ensure that ledger is accurate. But if you don't want to trust that and you want to trust nobody, or you want to trust everybody, it's the same thing. Then like how do you facilitate that system? So like blockchains as a data structure, kind of a cryptographically linked list structure, just intuitively made sense. And learning how does proof of work achieve consensus, then it kind of made sense once you have this distributed ledger that everybody kind of contributes to, but nobody can directly control or influence. That property of immutability, that anybody can access it, it's fully permissionless. Anybody can add entries, but they can't remove entries. Like those are like the very basic first principles of like what a blockchain is. It's just a data structure, but it's a very useful type data structure. Then it's kind of learning, okay, what can we apply this data structure to? Well, money. That seems like a pretty obvious one. If you want to have non-state money, not a money that's not controlled by central banks effectively, then you need the community to control it, and you need everybody to come to consensus, and you can have these predefined monetary policies that either no single person can change, or everybody can agree to change it. Like it's that property can be applied to anything, can be applied to agreements between different counterparties who don't trust each other. They don't want to trust some other entity. They can't trust their counterparty to run the contract. They don't want to trust some third party who can screw them over. So they want just a decentralized entity to manage that contract for them and run autonomously and just basically execute. It's kind of this concept of like the God protocol, where if you were able to have God run all the contracts and all the logic, then that would be like the ultimate counterparty that you could fully trust. Now, obviously, that's kind of like the idealistic vision, but smart contracts are kind of trying to achieve that state of you don't have to trust it; it will just work, and you can verify that it will just work. And those properties can be applied across so many different things. Money and agreements are the most obvious, but I think we're still exploring of like where else could we use it in gaming, in traditional finance, in social applications. Like the applications are unlimited, but it's really verifiability, transparency, permissionless, and of course censorship resistance.
Yeah, for sure, man. I totally hear you. Like, I recognize how silly it is for me, some like guy wearing a Bud Light shirt here, to make this comment, but like, sometimes I look back at like Satoshi and the original work around Bitcoin and wonder, at the same time that we know that it had to be speculative and investment to, kind of get us to where we are today, it in a certain standpoint, that has like really crippled us to just think about this whole technology and whole sector as something that is directly about money, like the most basic transfer and like unit of value that exists. And so, like, of course, that's important. I mean, look at everything that's been built; it's all about money. But I think kind of what you're saying and what I really, really believe is blockchain technology, and like I'll just do it and be like the maxi here, but like Ethereum specifically was not put on this planet to give us better money. It is a computing technology. And like there's just in the same way that modern computers, all they do is not just Swift or the financial system, they do so much more. Like that is what Ethereum and what blockchain is going to be for us.
Yeah, I kind of see like there's two different crypto worlds, or like, there's the builders who see the technology, and then there's the speculator and investors. And you kind of need both. Like if you don't have the speculators, you don't have the fundraising and capital for the builders to build. And if the builders don't build, there's nothing to speculate on. So like, they're intrinsically tied. But the speculation can also obviously get way out of control. And I mean, that's why crypto has such a terrible reputation of people see monkey JPEGs trading for six figures and they don't really get it, because I don't think most people really get it, because it's just a speculative mania. It's kind of like the dot-com bubble where, there was overinvestment effectively, and 99% of things just completely failed and didn't work out. But that capital funded the infrastructure, and that 1% went on to basically redefine how society itself works. So I think like speculation is a tool that can be useful. At times it could just get a bit too mania, and if it becomes the central focus of what's being done, then it's like you're building a casino, not how the future of society and its contractual agreements will work. So sometimes it just needs some alignment, but like, yeah, speculation isn't necessarily completely bad. It's just it's kind of a necessary evil, is the way I kind of see it.
Yeah, for sure. I mean, I think the second you get into the game of calling things good or evil, like you're not a builder anymore, you're a pundit, right? And so like speculation just is what it is. And I think the dot-com boom is the exact right analogy, right? Like pets.com, Webvan, super silly shit. But at the same time, that's when Google and Amazon and I don't know, Salesforce were being built. And like those are the pillars of our modern life today. So I think we could go on all day about the casino that we live in and what that means, but let's just try to keep this relevant here. So in 2017, 2018, 2019, you have started to realize both, probably organically, but also through the introduction of the Chainlink white paper, both how critically important oracles are going to be, but also like the capabilities that oracles are going to unlock. So for all of us now in 2023, like that's such a no-brainer, it's almost not worth talking about. But can you just rewind us a little bit back to that time and tell us like what for you was the aha moment that made you realize that, I mean, essentially you were going to build a whole identity around the power of this specific technology?
Yeah, I think there was like a particular moment in 2018, and just to set some context for people who weren't around back then, like crypto in 2018 wasn't about, like, there was no DeFi, there was no applications. Ethereum was effectively a fundraising platform for ICOs and tokens, people speculating what could be built. And what really clicked about like oracles and ultimately Chainlink is there was somebody wrote this thesis of like, what would an institutional smart contract look like? What would that require? Would it just be the on-chain logic? Well, no, they need financial market data to settle their financial transactions. They need to be able to connect to institutional backends so they can send messages and connect their existing infrastructure. They need to be able to connect to existing e-signature providers. They need to connect to existing payment providers. Like there's going to be this transaction period, and they need all the existing infrastructure that we already use today in the financial industry or the tech industry or whatever. That's not going to just like disappear with blockchain and smart contracts. That'll be connected to smart contracts to kind of create these hybrid applications that can effectively, for smart contracts, not just be this logic on chain, but it can connect to the outputs and the inputs that are required to make a full contract, because that's ultimately what a contract is. You have some input of this is what's going to happen, and then that has some output, usually like the transfer of funds. So like you need both of those IO components. And like when I read that and I kind of realized, oh man, if we're actually going to get smart contracts to do anything useful at scale, bring an on-chain financial system for traditional securities, or whatever contractual agreement, like it's got to connect to all this infrastructure. It needs the inputs, it needs the outputs, and it ultimately oracles even evolved beyond that. But that was kind of that was the one moment where I was like, oh man, okay, this is like oracles are just as important as smart contracts. Like we could use smart contracts without oracles, and they would still be kind of useful. But you can basically create a token, move a token, swap a token, and vote. Those are like the four things you can do without oracles. And if you really want to do anything more, then you need some type of information coming in and out of the system to other systems. And that's how smart contracts become globally, systemically important and integral to the way society works. So that was really the aha moment. And then once I read that thesis, then I went and read the Chainlink white paper, and then it's like, okay, this whole thesis makes a whole lot of sense to me.
Yeah, you started with the theory and you're like, okay, now I understand how this like basically like self-contained internet tool that like might have some applications to video game assets transforms into like, okay, this is the global financial system of the internet age. And then you read the Chainlink white paper and it was like, well, this is how we actually do it. Does that sound right?
Yeah, exactly. Because it was just like, here's what institutions need from smart contracts. And okay, and the answer was basically oracles, and like Chainlink's basically the only project working on oracles. And at the time, it was just a white paper, but like, okay, yeah, this is obviously this is going to go somewhere. Look at all the people that they've been working with. I mean, it was already known that Chainlink was working with Swift and DocuSign and these other people. So it's like, okay, maybe these guys know what they're doing. This is one of the more interesting projects in this space.
Yeah. Well, man, good for you to be able to recognize like what things are actually interesting and what things are like meaningless hype. Because as we all know, crypto Twitter is not very good at that. But good job like catching that early.
Yeah, I mean, I was definitely like, I originally got my news from like Reddit r/cryptocurrency, and so like I went through the whole like, I'm not gonna name them because I don't want to piss off any communities, but like all these other coins that like they look like they have good potential, and then you kind of dig into it and realize like, okay, they're not really solving anything useful, and so like, you kind of, I think everybody kind of goes through that path of like what's actually useful for this technology and what's just kind of hype and vaporware and marketing campaigns.
Yeah, no, and it's interesting that everyone has their own, like, for me, it was the alt L1s. Because for those of you who are unaware, I am a 2021 baby, so I'm relatively new. And I immediately got in and thought, okay, there's Ethereum, there's Ethereum, competitors, like, which one's going to win? I need to have, like, a little piece of all of them. And then over time, you realize, like, okay, just because somebody says the right words doesn't mean they're building technology that's going to change the world. And it's just interesting that that exact same thing happened for me on the L1 layer because that's when I entered. And the same thing happened to you at the, I don't even know, just like random token or ICO layer because that's when you entered.
Yeah, it was like a mixture of different L1s and different projects. I think a lot of those kind of got flushed out for the most part, and then it kind of got replaced by like a new set of hyped up things, and then every cycle it seems to repeat with a different set of tokens and projects. Some make it, some don't. It's just you gotta be able to filter really well in crypto, otherwise you get very distracted very easily.
For sure, for sure. So let's go back to our story. And I don't think it's like particularly useful to just pick apart the entire Chainlink story, but if you could just kind of give us the highlights of Chainlink from white paper to, let's say, in the last couple months, let's say pre-launch of CCIP, like what, like how does this go from a white paper and then I'm assuming just like one guy running one set of nodes to put data on chain to a truly decentralized network that's creating robust enough data inflows and outflows that people are building multi-billion dollar protocols on it. Yeah, what are the highlights of that journey?
Yeah, so like the original token sale was 2017. That's when the white paper came out, and then it wasn't until 2019 where Chainlink launched on mainnet, and that was with a like ETHUSD data feed on Ethereum with three nodes, and it was effectively just feeding data on chain about the Ether price every 5 minutes, and that was like the initial product market fit of oracles at the time, and it honestly didn't really get used that much until 2020. And then 2020, that's when we saw DeFi Summer, which was this absolutely crazy liquidity mining fueled craze. But a lot of DeFi Summer and a lot of the applications that popped up during that time were only possible because Chainlink was putting price data on chain about various different cryptocurrencies. And as more applications and more user demand popped up, more and more feeds got launched with more and more nodes, more data sources. That eventually expanded out to more blockchains. As kind of as you mentioned, the all L1s start popping up. Then all these other blockchains need DeFi applications, but they need oracles and price feeds to make that possible. So that's kind of where I think a lot of people first heard about Chainlink for the first time, was just its usage in DeFi as price feeds, and that kind of created this perception or understanding that like oracles are price feeds, which that's historically one of the major use cases that they've been used for. But like once Chainlink was kind of established as this like price feed provider for the DeFi ecosystem, then it was kind of the next step was like, okay, what else can oracles be used for? Well, they can be used for verifiable random numbers for like NFT mints or for gaming applications. Okay, that's useful. Smart contracts can't trigger their own functions, so you need some transaction automation solution. So then automation came out. You have all these stablecoins and these wrapped tokens that are backed by assets off-chain or cross-chain. So having proof of reserve is useful to verify it's actually backed by something. So it kind of just accelerated from there of like all these different use cases until uh, where we kind of are now, where there's basically the way I see it is Chainlink's making like three major bets across external data, off-chain compute, and cross-chain interoperability. So on data, there's Chainlink's building new infrastructure for low latency data feeds, which are like data feeds, but rather than just pumping data on chain, the data is made available off chain to users, and users can put it on chain whenever they want using the freshest data. So that's very useful for derivatives applications like GMX, which have a lot of leverage and need the most fresh, most secure data. The second, like computation, is something called functions, which is basically using Oracle networks to run computations off chain and being able to fetch from any data source. So you can do any type of computation that would be too expensive or too infeasible or needs privacy that you don't want to do on a blockchain, but you want the results to end up on a blockchain. So that's like a very useful developer-focused self-service tool where you can basically plug whatever you want into your smart contract, any compute, any data. And then the third that you mentioned is cross-chain with CCIP. So that's the cross-chain interoperability protocol that Chainlink just recently launched on mainnet early access, which is effectively, we've seen cross-chain bridges over the past year or two. I think last year was like $2 billion got exploited in cross-chain bridges. It's been not great because a lot of the bridges have rushed designs or they're poor quality or they're just not secured very well. And Chainlink price feeds, like Chainlink's reputation is just based on how well it's worked, how secure it's been running, and how it's had basically virtually no issues. And so it's applying that same security logic to all these services, including cross-chain, which has been such a security sensitive problem. And Chainlink's effectively providing this cross-chain solution with these different layers of security for not only the DeFi ecosystem, but now is working with traditional institutions of, okay, how do we connect the public chains with the private bank chains? And how do we connect the bank's backend system to all these blockchains in a very seamless manner so we can see institutions start to tokenize more assets? So it's kind of, I've always kind of seen Chainlink as trying to push the industry forward. It's always kind of just one or two steps ahead of the rest of the industry, kind of laying the road so developers can go build and use the infrastructure to build out what eventually becomes the next trend and what becomes the next, applications that people end up building. So it's really been a journey from just price feeds, one network, to all these different networks with all this different computation and data and interoperability. And it's kind of Chainlink's basically like this Web3 services platform where you can pick and choose, kind of like AWS, where you just pick and choose the services you need, plug it in your smart contracts, and then you basically get going. You don't have to think about the infrastructure complexity or anything.
Yeah, for sure. I love the kind of three pillars. So let's address each one of the pillars with spending the most time on CCIP, the new one. But even before we get there, let's talk a little bit about like the ChainLink Oracle network, right? And I think it's hard for people who don't live and breathe like our the way that we think and the way that our systems are constructed to like first like understand that it's a challenge to get external data onto Ethereum, which exists solely over the internet. But then on top of that, like we get into like these huge questions of it's one thing to put data into this trustless environment, but basically the data is only going to be as good as what is put in. And so like the question immediately becomes like, how do we trust the data that's put in? And so can you just talk a little bit about what is the Chainlink Oracle network? Is it something like Ethereum where it's permissionless, like anyone like myself can opt in to be an Oracle node? And then kind of how does Chainlink as a holistic system ensure that each individual participant is, of course not malicious, but even more than that, like actually putting like their full effort into getting the most accurate possible data or execution or whatever role they're playing in the network?
Yeah, just to set some context, like basically what Chainlink effectively solved was the Oracle problem, where smart contracts and blockchains are these self-isolated systems. That's what makes them so secure. You can run a blockchain node and you can verify everything that's happening using just the cryptography and historical state. But if you want to introduce any kind of external information, smart contracts can't reach out and go get that data, because then every node's going to get a slightly different thing and they can't come to consensus and it breaks the whole security model. So you need these other entities called oracles, but you can't have just one entity go fetch the data and put it on chain, because I mean that becomes an obvious single point of failure. And if your contract is triggered by one entity and you could just corrupt that one entity, it kind of defeats the point of using smart contracts in the first place, or it becomes very, very insecure to do it that method. So like Chainlink basically introduced, there's different ways to describe it. I see it as like a framework for building Oracle networks. So the Chainlink network is really a network of networks where people have the tools to basically say, hey, I want this collection of nodes to fetch from this collection of data sources, come to consensus, and feed it to my contract. So there's not just one Chainlink network. There's actually about 1,000 Chainlink networks across different blockchains, and each one of those networks can be configured to do a specific task. I kind of see it as like consensus as a service. So if you need consensus about the prices of ETH/USD, you can set up an Oracle network with any nodes of your choosing, any data sources, and you can get exactly what you need. And some of those networks within this collection are networks that are basically bootstrapped and managed by Chainlink Labs to kind of fuel the growth of the Chainlink ecosystem. And those are node operators who span different industries, like traditional telecommunication providers like T-Systems, which is T-Mobile and Swisscom, and these traditional enterprises. There's proof-of-stake validator companies that run blockchain infrastructure basically as a living, as a company, so they know how to run this infrastructure. And then there's like community actors who basically they run Chainlink nodes as their business. And so basically what secures these different Chainlink networks is a combination of a couple different things. When you have multiple nodes and multiple sources, you have decentralization. So it's kind of applying the same properties that blockchains take to transactions, to data and compute, and all these other things. And layered on top of that is effectively financial incentives, where node operators have, they're getting paid for their services. They have this future income that they don't want to jeopardize by being malicious. And they have their reputation on the line, whether like specific legal risks or just their future revenue and their whole company on the line as a service provider, as well as Chainlink's been rolling out what's called Chainlink staking. So node operators are paid in Link token for their services, so they want to maintain the value of the token. If they're malicious and that harms the value of the token, their future revenue and all their Link holdings basically become worthless. So they have a financial incentive not to harm the health of the network, as well as Chainlink staking rolls out, increasingly rolls out more and more. Node operators are required to put up Link tokens as collateral to basically back the performance of their networks. And if they don't meet some predefined condition or some requirement of them, those tokens can be slashed and taken away from them. So it's not exactly proof of stake as we see in blockchains, because it's not a blockchain, but it's the same kind of security properties that you would see in a blockchain, just being applied to the context of oracles, which there's similarities with blockchains, but there's definitely differences. Oracle networks, it's with Chainlink, anybody can build a network and compose it however you want. And usually it's better if like the entity who uses the network or coordinates the network chooses which nodes are used. So that way you have predefined requirements of those operators, because they need to do specific things. And not every Oracle node is going to be able to do every Oracle job. Realistically, the network wouldn't be able to scale that way. So it's a little bit different than blockchains in that regard, but it's basically all about configurability and then applying decentralization, financial incentives, and then cryptography via digital signatures, all in kind of combination to create this system that looks like blockchains, but is for data and for computation and cross-chain.
Yeah, it sounds like you're taking all the learnings about consensus that have been derived from blockchain, but then applying it to things that are just traditional compute, right? And so it sounds like you have the hybrid of the crypto economic systems, but with like modern compute. And I think that's super cool. But one of the things that I have been thinking about as you've been talking is really about like the complexity and the challenge of having like super wide diverse networks, right? Oracle networks in this case. And so do you ever, and by you, I mean Chainlink, ever like have to think about or struggle with making sure that enough people are interested in running Chainlink nodes and that those people are sufficiently diverse that we achieve true decentralization in this network? Or is the model more about leaving that to the application developers insofar as that they get to select their Oracle network?
I think it's kind of a mixture of both. I think Your users should be able to pay for the security that they want. So if they need to fetch a data point from a specific data source, like an IoT sensor, and that's the only data source, then adding decentralization there at the node layer doesn't necessarily do much because you're already trusting a single source that already exists. So you kind of need some configurability there. I would say that there's more outsized demand to run Chainlink infrastructure than there is supply. And by supply, I mean basically the current economic revenue that comes in, because you want to create an Oracle network that's long-term economically sustainable. So if you have an Oracle network with 1,000 nodes, that would be very decentralized. But if you don't have enough revenue coming in to support them, then your network's actually less secure than if you had a network of like 30 nodes that have these really strong economic incentives to keep up their operation. So it's kind of, you have to kind of balance these different things in combination, but ultimately the goal is to basically provide the infrastructure and tooling so a dev can come to the Chainlink network and say, hey, I need this data source. I want to have at least 50 nodes. I want to use these 20 data sources. These are the configurations. This is what I'm willing to pay. And then you basically get matched with node operators. And that's kind of like the long-term vision. Right now, Chainlink Labs is kind of helping bootstrap the ecosystem by saying, okay, we're going to launch this Oracle network with these 30 nodes pulling from these sources to deliver this data point that users are asking for. And kind of a lot of developers don't necessarily want to manage their own infrastructure and they want more of a managed solution for them, but they still want to be able to pay for more security. So it's kind of, you have to balance the decentralization with the economic incentives that exist there to make sure it's sustainable in the long term. But ultimately, it's about configurability.
Yeah, for sure. That makes a lot of sense. And I think a lot of the questions that we have about any of these blockchain technologies today is just, like we have to build it first before anyone can use it. And like that's a really, really scary thing, especially as an investor. But that's kind of our jobs as like community advocates to help people understand, and yes, to help retail understand why this stuff is important. It's going to change their life. But I really look at my project in Strange Water podcast as like my mission is to talk to application developers about Ethereum and Ethereum related infrastructure, because like everyone who is building web apps and applications for real people don't need to worry about how all this shit works. They just need to know what capabilities like they can now gain if they just like do really, really simple integrations with what we're building.
Yeah, ultimately, it's kind of a balance of like you need to provide the infrastructure and the tooling so developers can build cool applications, but you don't necessarily want to build infrastructure that doesn't end up getting used because then you've wasted effort and resources. And so you kind of have to like, you got to prioritize, okay, developers really need low latency price data. They really need a cross-chain interoperability solution. Identity solutions is going to be important, but maybe it's a little early stage for that just now. So it's kind of like matching what do developers need, building the infrastructure just in front of them so they can keep moving, and then it's like laying track in front of a train that's moving effectively. So you kind of can direct developers, but the developers know what they want to build and they're going to build where they're going to build, which is kind of, people see risks with cross-chain where it's not completely trustless cross-chain interactions, but developers want to build that and users want to move their tokens cross-chain. So there needs to be some type of cross-chain solution. Otherwise, we'll have to trust Joe in his basement to move the tokens between blockchains, and that doesn't work and that doesn't scale. So the developers and the infrastructure builders basically have to like meet in the middle and then build out, and then retail's kind of along for the ride, effectively, or rather, they're using the applications. They're the ultimate users of this entire thing, depending on what type of retail user they are.
Yeah, just to put it in a much more crass way, like we have to be building these solutions right in front of developers, because otherwise, like, what's the choice? Just to rely on Wormhole and then just hope that Jump has more money than the North Koreans are willing to steal? Like, come on, that's not a solution.
Yeah, exactly. With the Ronin situation, or with, I mean, I can name like a million different bridge situations. Multi-chain's probably the worst example.
Yeah, for sure. Cool, man. All right, so let's go through each of these buckets, the three pillars individually. And I don't know how much there is to say about just data available. That's a loaded term. I'm not going to say data availability, but being made available on chain. Do you think that there's anything that we haven't kind of like ambiently talked about that's worth talking about?
I mean, the main thing is price feeds or price data, because that's the most obvious product market fit for a DeFi ecosystem. But like realistically, if you have like an insurance agreement about like crop insurance, you need the weather data to come on chain. If you have some trade finance agreement or some trade agreement, you need like GPS location data. So it's like there's all these various random different data points that some smart contract could need, and so just having infrastructure ready to plop that data on chain in a secure and trusted way is immensely valuable. I think price data is not going to go away. I think the focus may shift from like just what's the price of Bitcoin to like what's the price of Apple stock realistically if we're going to move towards tokenized assets. But the fundamentals, like we've tested that this infrastructure works in the DeFi context, and as things move more institutional and more societal scale, the same learnings and logic apply. It's just a different types of data you put on chain. So it's kind of everything's proved useful, even if DeFi in 10 years looks completely different than it is today.
Yeah, that makes a ton of sense. And I really think that at the end of the day, like we're humans and we exist in the physical world. And so it's important to build products like Ethereum that matter to the physical world. And so, yeah, I totally understand why data transfer in and out of the EVM is so important. I guess last question in this pillar before we move on is there any type of data that you know or foresee is going to be a challenge to integrate into an Oracle network? Or is the power of modern computing that if a computer can ingest it, then Chainlink will be able to ingest and then find consensus on it?
Yeah, I mean, ultimately, if there's a data source, ideally multiple, it could be ingested and put on chain. The tricky part is when you're dealing with like subjective questions, then it's like things where there isn't a definitive truth to them, where it could be interpreted in different ways. That's an area where oracles aren't necessarily the most useful if everybody can interpret something in a different way. But if you have a very objective data set, then it's relatively easy to come to consensus. Like transactions and blockchains are easy to come consensus on because everybody can verify for themselves, see that it's legitimate, and then everybody can agree. But if people can't agree about the outcome of some specific event because people don't have all the information at hand, or people have different political views, that's something where basically you kind of need more humans in the mix, and you can't automate via oracles and smart contracts as well. But even things like price data, it seems like that's a very objective data point. But when you look at the trading of tokens, they happen across all these different exchanges, on chain, on different chains, off chain on these different exchanges, different amounts of volume and liquidity and latency and like all these different factors where even trying to get like a consensus on the price of a token isn't always necessarily super straightforward. And we've seen a lot of issues with price feeds with other projects where they think they could just pull from two exchanges and that'll be fine. Or I just pull from this one liquidity pool and I'll be fine. And then liquidity shifts and then the protocol gets wrecked because they didn't capture the entire market. So like even something as simple as price data can be easy to mess up if you don't get the nuances of what data you're trying to put on chain in the first place. So but yeah, I would say objective data is the most clear because that could be automated very easily, and subjective data is more kind of almost out of scope of smart contracts entirely.
Yeah, the one that I'm thinking about in pricing data is like, let's call the price of ETH 1600 right now. If we go query our data sources and Coinbase says 1600 and Kraken says 1600 and the Uniswap LP says 1600, but Binance says 1550. It's easy in our heads to be like, all right, consensus says that like this probably isn't right, or we need to find some way to blend this new number in. But, like that's not really how the world works. Like maybe price is being set on Binance and like everyone else is about to reflect that. And so like, yeah, price isn't an objective thing. And it's the closest thing we have to objective data. So it's just like, it's very interesting that the more you really peel back Oracle networks in terms of like actual specific data sources and actual specific computers and actual specific needs, like things get a lot more nuanced and complicated.
Yeah, I mean, with Chainlink, it's basically you just got to layer on like a bunch of validation systems, or you need to filter for outliers and filter for flash crashes. You want to get like the volume weighted average price across different exchanges, and like it's like once you kind of dive into the nuances, it seems obvious, but then you see somebody implement an Oracle that just fetches from Coinbase, and they call that their price feed, and it's like, oh man, that's no good. But like, it's not everyone necessarily understands the nuances behind that, which they shouldn't have to, realistically.
Very cool. All right, so let's move on to something that I think is way under talked about with Chainlink, which is the ability to execute arbitrary code using the Oracle network. So I could probably explain it. I'll totally butcher it. Do you want to just like tell the audience like what is this product that we're talking about?
Yeah, so there's a couple different ones that could actually apply here, but I think the one that applies the most is Chainlink Functions, which is kind of what it sounds like cloud functions, but it's effectively, as a developer, you can give the Chainlink Functions network a JavaScript code snippet, any arbitrary code basically, give that to the Oracle network and it will execute it, and you can incorporate like different API calls. You can call data sources, you can run computations over those inputs, do large amounts of computation that can't be done on chain, or do computations that need some layer of privacy, or what other type of computation that you can't or don't want to do on a blockchain. Then you just submit the final result to a blockchain to ingest. So basically that's kind of, it's a similar thesis to how like Ethereum scaling via layer 2s. It's like you're using the blockchain as a final settlement layer for the transfer and settlement of value, but the complex operations are being done off chain and basically just being verified on chain as being legitimate. And so like that's a very intuitive way of scaling these different ecosystems and being able to incorporate data points that you're not just pulling from a data source, but from many sources, and then you're computing on them and you're ingesting different types of computations across them and then putting the final result on chain, which that could be used for many different contexts of connecting to traditional cloud services, connecting to other blockchains, connecting to like IPFS type networks, or like snapshot voting and getting the final results and putting that on chain. Like it's kind of a whole spectrum of different things you can run off chain for much cheaper and much faster, while still retaining the core properties of smart contracts that people want ultimately.
Yeah, so let's talk let's just bash through a really quick made up example, right? But let's say like I'm a hedge fund and I want to create a program that goes on GMX, calculates every specific parameter, and based on a very intense calculation decides to make a buy or a sell, right? That may be possible today, but it's probably prohibitively expensive because the way blockchain works is the more computation, the more you pay in gas. And on top of that, if you want to include any external data, like you have to pay an Oracle network or figure out some trusted way to get it in there. Like the bottom line is Ethereum won't let you do it. And so what Chainlink Functions allows you to do is send basically your inputs, like this is how much money I have. Say, like, I want you to ingest this specific chain data, and then I want you to pull from these different weather sources, weather or any external data sources, do all this intense computation, and then when you're done, just give me back to my smart contract, yes or no, buy or sell, right? And so I guess, first of all, can you just like let me know if that example doesn't hold? But if it does, can you talk about like why it's so important to run that kind of computation in an Oracle network as opposed to just, let's say, like spinning up an Amazon server that is running that same computation that you control, sending out that function, and then getting it back from that AWS that you control?
Yeah, I think that example definitely works. I think it's most useful when the output that's being generated will affect multiple people. So if it just affects yourself, then might as well just run it yourself because you trust yourself. But if your output from a computation is going to affect multiple different parties, like it's for a DAO, or it's for some smart contract that has multiple counterparties, you can't just trust one of the counterparties to run that computation realistically. I think ultimately, like the goal is like it's multifold, where it's much more scalable to run these computations off chain. You can run it constantly. Like you don't necessarily run a computation once. You may run it 1,000 times because there might just be one moment in time in which the computation actually ends up being relevant. And so doing that on chain just is not feasible at all realistically. If you want to like ingest data, particularly like data that's private, and run computations over it and output some analysis from that data, you don't want to do that on chain because you don't want to put the raw data on chain and run the computation there, because then that doesn't work for privacy reasons either. So you need to run that off chain, but you need to run it in a trust minimized and kind of secure private manner as well. So I think that ultimately it's kind of the creation of what you can call like a hybrid smart contract, where a portion of the logic is running on chain and the other portion of the logic is running off chain at a much higher speed and in a much more private manner that can connect to all the external resources, whether it's Twilio for SMS, or it's Meta for social media, or whether it's Google Cloud for various different server functions they have. Then it just outputs, yep, this computation happened, this was the result. You can use this to instruct a smart contract to move the transfer tokens from one party to another effectively. And I think that model of running computations off chain and verifying the result on chain, that's kind of similar to what layer 2s are trying to do, but specifically for smart contracts and holding money and moving tokens on layer 2s, while functions is much more about any arbitrary computation that's too expensive or the blockchain doesn't even have the capability of doing those types of computations, like more very intensive AI calculations or machine learning that realistically you can't do on top of a blockchain itself. So it functions as a cool product because it doesn't have a definitive use case. Its use case is just computation, and computation is like universally applicable to anything. Plus, you can connect to any data source and have it fetched and computed by this trusted decentralized network of Oracle nodes that already run all this other Chainlink infrastructure and have these financial incentives for you. So it's up to the developers to choose, okay, I don't actually have to run this off chain. It would be much better if I ran it off chain because I could run it a million times over and I can incorporate all this data otherwise I couldn't use in the first place. So it's a really useful tool that a developer can have in their toolkit to apply when it's used best.
I think like the thing that's like so interesting about the way we're talking about Chainlink functions is that we're using a lot of the same vocabulary and ideas that basically is driving the entire narrative around ZK technology. And so basically, like if I was to sum up ZK technology in a sentence or two, it's how can we use cryptography to execute computation off chain that might be super intense or crazy to do, and then put that result on chain. And then instead of having to rerun this crazy computation to verify it, we can do a very, very lightweight, simple cryptographic proof using that commitment. And then we like can basically like be assured that our function was run properly. And so I guess with that as like kind of the context, how do you see ZK technology fitting itself into this like incredible Oracle network that basically solved the problem that ZK technology was invented to solve? And do you think that this is really two kind of parallel solutions that like can learn a lot from each other, but ultimately, are solving the same problem from two different first principles? Or do you see ZK technology as a like really important, crucial upgrade to what Chainlink has built so far?
I think they're definitely complementary. I mean, ultimately, oracles bring consensus, cryptography, and financial incentives to run computations and fetch data. And I think zero knowledge proofs are really scalable of running complex computations and then making it very cheap to verify and being able to also retain privacy. And so Chainlink has actually been engaged in research on a product called Deco, which is a privacy preserving oracle using ZK snarks, where you could basically bootstrap a privacy preserving identity protocol where existing data brokers, existing data providers can basically provide certificates of like proof of identity, proof of that you've done something, and then smart contracts can use that without knowing the identity of a specific party. So like an example is if I want to prove to a smart contract that I'm an accredited investor, so I have at least a net worth of $1 million, but I don't actually want to reveal how much money I have or I own, you can use Deco, which is Oracle's plus ZK Tech, to basically prove, hey, cryptographically, this data source that I connected to was a legitimate connection, and that this data provider says, it could be my bank account or something, or a collection of bank accounts, says my net worth is at least over $1 million without saying exactly how much it is. So I think like when you apply ZK, you get both like the major privacy benefits with oracles, which is very important for identity protocols, and you get this just the cryptographic verification that, hey, I did legitimately fetch data from this data source, since ideally data sources would cryptographically sign their APIs so you can prove, but most of them don't, unfortunately. So you can use ZK proofs to basically connect to any existing data provider in a backwards compatible manner and prove cryptographically that you did actually fetch from that data provider, while only selectively showing the information or facts about the information, some computation about it, to the smart contract itself. So I think ZK and oracles are 100% complementary, and I think that'll continue to evolve over time because ZK is all about verification and privacy, oracle is all about consensus and financial incentives.
Yeah, maybe a good way to put it is that it's really easy for us in ZK world to be like, ZK is going to solve all these trust problems, and I think that's true, right? But the question that we often don't bother asking ourselves is like, super cool that we can cryptographically verify all this stuff, but like somebody actually has to run the computation. Like we're just assuming that there's a bunch of people willing to do this stuff out there, and that once they do it, we can verify it with cryptography. And I think maybe where this marriage point is that Chainlink is that what is an Oracle network really? It's a computation network, and maybe Chainlink is like the organization, and ZK is like the tool that the organization needs.
Yeah, exactly. I see Oracle's as like consensus as a service, or like you can basically just do you can have an Oracle network do whatever you want it to do. So if you say, hey, Oracle network, go run the ZK proving function, it'll take like, a minute or two to prove. I'll pay you for the computation, send me the results. Like Oracles are just basically facilitators and they can facilitate whatever you want. Plus you can use those same entities for all these other things that ZK proofs can't necessarily do or they're not optimized for either. So it's like an all-in-one package. You get the ZK proving and you get all these other services to serve your smart contract all at once. So I think that's a very powerful property where, I mean, Chainlink's value, a large part of it is just its high quality node set and just the reliability of the network itself. Because if you want to run ZK proving computations, you need to make sure it actually happens and that somebody's being paid to do that and they're incentivized and the result will actually get on chain and do what it needs to do. And so basically leveraging existing Oracle infrastructure to do those computations is like it's a perfect match for one another.
Yeah, for sure. Okay, let's move on to CCIP, which is like the newest and the latest and greatest release or development from Chainlink. But CLG, could you give us like the 411 on CCIP with the specific like filter of why is this a distinct pillar and not just part of the function category?
Yeah, so CCIP, the cross-chain interoperability protocol, was basically built from the ground up to provide the most secure cross-chain messaging and cross-chain token transfer solution for public and private blockchains. So when you can kind of think of an Oracle network, or rather, you could think of a cross-chain bridge as an Oracle network where the data source is another blockchain, effectively. But you have to deal with the unique properties of blockchains that they can reorg, and they can basically a transaction that was once on the chain is no longer there and you're directly moving the transfer of funds from one chain to another, or it's kind of abstracted away, but that's basically what you're doing. So you're not just moving data, you're moving tokens and value. So like the security threshold that you need to secure that is even higher than what you would see for data and computation because the incentives to corrupt it are so much higher. So CCIP basically takes the approach where there's multiple Oracle networks actually that work in combination, where you have an Oracle network that reads uh, a transaction that needs to move cross chain and commits to it on the destination chain. There's this independent network called the Risk Management Network, which runs completely independently. It runs in a different code base. It was developed by a different team to basically validate was that commitment, that cross chain commitment, actually legitimate? Was that what the original sender actually said? Is this like does that transaction actually exist on the source chain still? And then once that's been approved, then there's a commitment Oracle network that basically executes whatever that cross-chain execution was supposed to be, like moving tokens or swapping tokens or doing whatever on the destination chain. So like you have this multi-layered security with this secondary validation network that ensures CCIP is actually executing what it's supposed to be executing. And I think that's kind of a unique approach where a lot of cross-chain bridges are just like one validator set. They see something happens on another chain, they move it to the other chain, it's done. But that can lead to problems with reorgs or that network can become corrupted or conflict of interest or whatever. So having this secondary validation network is really that's like the secret sauce that actually makes this interaction secure to ensure that the executions happen as they're supposed to. And I think interoperability is blockchain to blockchain. So public to private, private to private, public to public, all these combinations, but it's also interoperability with traditional systems. So if you're a traditional bank or institution, and there's hundreds of blockchains, L1s, L2s, L3s, the work required to integrate with each one of those chains is intensive. And if you want to move the assets between those different chains, you have all these different bridges to choose from. So CCIP also offers institutions like this abstraction layer where if an institution just connects their backend system to CCIP, they can connect to any public or private blockchain and move assets between any of those supported chains as well. So it's kind of an all-in-one interoperability product that I think a lot of other bridges, they're not even stepping that far. They're just focused on moving random tokens between Ethereum and Solana and Avalanche or whatever other chain. But if everything's going to move towards institutions issuing tokenized assets, currencies, equity, commodities, whatever on chain, they want to get the greatest liquidity. They need to access all the different chains their counterparties use. They need a really simple solution to do that. So interoperability, connectivity, whatever you want to call it, is like a crucial property that CCIP is directly enabling.
So I'm super curious to Because like on the one hand, the way that I'm understanding CCIP as you sketch it out is it is like all of the best, as you said, it's built from the ground up, so we're not taking anything from the earlier products, but it's the all the best ideas from the original Oracle network and Chainlink functions, but it's like re-engineered from the ground up to be specifically about blockchains and blockchain security, right? Which is awesome. But you're also talking a little bit about how like institutions, like let's just pick Wells Fargo, like a huge bank, right? Would Wells Fargo use CCIP to integrate their IT system with let's say Ethereum and then all of like the other ones, but let's just keep it to Ethereum for now? Or is this yeah, is that the direct connection by which they're transferring assets, they're sending Ethereum transactions, or is that really a data network that allows them to then interact with Ethereum directly?
Yeah, so I'll use a specific example with real bank names versus hypothetical, because why not? Yeah, Chainlink recently did a collaboration with Swift, the interbank messaging system that's used across all banks, and there was 12 other financial market infrastructure providers and institutions, DTCC, Euroclear, BNY Mellon, ANZ, Lloyds, all these different entities, where they basically use CCIP to connect existing Swift infrastructure where banks already have Swift messages. That's how they communicate with one another. They want to use that existing Swift infrastructure to send messages and commands to blockchains like Ethereum. So rather than rebuild the entire tech infrastructure on their back end, which they don't want to do because these mainframes from like the 70s secure trillions in value and they don't want to touch it because it works, but they still want to connect to this new technology, they can use CCIP to basically send messages to blockchains so they can issue assets, they can interact with smart contracts on Ethereum or other chains, and they can also use it at the same time to move their tokenized assets cross-chain, which means if a counterparty has tokenized cash or stablecoins on one public chain, and another counterparty has tokenized bonds on a private chain, and they want to trade with one another, without a cross-chain solution, you're kind of blocked effectively. But if with CCIP, you're able to do cross-chain tokenized asset settlement, where those assets move across the different chains simultaneously to facilitate those trades. So it doesn't necessarily matter what chain an institution wants to use. They can trade with every other institution who's also connected to every other chain and have their assets on specific chains that they prefer, and they can still trade with each other effectively. So that's kind of the message passing component of sending messages from the banks to blockchains. And then there's the cross-chain portion, which is smart contracts using CCIP to send messages to other smart contracts and other chains. And this whole flow is kind of all connected together. So the institution basically just doesn't even need to change anything. They just keep using their Swift infrastructure, and now they unlock all these tokenized assets and all these different global liquidity and all the benefits of smart contracts instantly through their existing infrastructure. But I think is to me seems like the most realistic path for institutions to actually adopt blockchains, because they're not going to throw out everything they've built over the past 100 years just to adopt a new technology.
No, man, for sure. Like the funniest thing you just said is about the mainframes and stuff. Like, very quick anecdote. I used to work first in IT and then in finance for Anheuser-Busch, which is, Budweiser and Bud Light. And like literally, in order to get like the real archival data, we would have to call someone who would go to the data center to pull the data off of magnetic tape in 2013 to 2018. Like that's really how our financial infrastructure is run, on like super, super antiquated technology. And so, yeah, it's super important to be able to integrate with how business is done today and not just like kick and scream about how we have a better solution and why don't you just like take the risk of migrating $1 trillion over, right? That's crazy. That's not going to happen.
Yeah, it's kind of the difference between like what's idealistic versus what's pragmatic. Like idealistically, everybody just ditches what they're using and adopts blockchain, and that's their settlement layer. But like that's so risky. Like you're not going to be able to convince a CEO or a CTO to take on that risk. When the benefits, they want to make incremental progress and see the results and then scale up over time. And so pragmatically, it's better just to connect the existing systems, and over time, more and more of the operations happen on chain, on whatever chain that they want to use, and then use like a standardized cross-chain solution to connect all these things together. So to me, it seems like a very practical approach, which I haven't seen with past implementations, which have been siloed gardens and pitching replace everything with a blockchain, which that's gotten enterprise blockchains a pretty bad rap because of the impractical approach that they're asking of people.
Yeah, I mean, listen, the only one that's going to win on the enterprise blockchain one is JP Morgan, the enterprise building a blockchain and not anybody building a blockchain for enterprise. So yeah, man, spot on. And I think like the most just like interesting, crucial unlock of this conversation is like really recognizing that like the point of Ethereum is to create this like untouchable, beautiful, pristine database, right? That's what the EVM is. It's just a simple database. And like, what is Swift? Like, yes, it's not a blockchain at all. Like, yes, there's no like consensus or security or whatever. It's like the most trust of trust-based trust systems trust, right? But at the same time, like all it really is a shared database between these banks. And so what CCIP does is say, not only can we connect Ethereum to its L2s or to Solana or Cardano or like any other chain, it's also about recognizing that all a chain is like a special purpose type of compute and database. And so we can connect a blockchain to anything that has the same properties, even if it doesn't come in the same package.
Yeah, exactly. And it's not about like throwing the baby out with the bathwater approach, where like Swift is like it's already used. They have like a network of 11,000 banks, and that Swift is really like a private key network. Actually, they're like the largest network of every bank has a private key, and that's how they verify messages with one another. So like private keys are used in blockchains. Like why throw out the whole system? That's pretty useful for blockchains already. So it's like this natural marriage between the two where I mean the trust assumptions aren't going to be the exact same of enterprises using enterprise blockchains versus using Bitcoin on the Bitcoin blockchain, but I think they're just different use cases of the technology, and people are going to use whatever version or implementation of a blockchain application that's the most relevant to them. And because all this technology is permissionless, nobody's stopping you from just if you just want to trade some tokens on Uniswap all day, every day, 24/7, like you're free to do that. Like that's your prerogative. But if you want to, use tokenized cash to engage in OTC sales of like traditional, securities, a lot of banks want to do that, and blockchains are way cheaper and way faster to do that, and can coordinate global liquidity with one another. That's useful as well. So it's like I think as like the years go on, the things we realize we can actually do with blockchain is just keeps expanding and expanding and expanding. And it's like those old use cases never went away. It's just we're finding new cool shit we can do with blockchains, and I think that's one of the most exciting things in crypto is that it moves very fast, but there's always new things happening if you ignore all the noise and the chaos that happens in the meanwhile.
Man, beautiful way to segue to our conclusion here. So, CLG, with the last few minutes, I would love if you could just give me and the audience just some of the things that you're really excited about for Chainlink, for oracles, and for blockchain. And if it is something directly to do with CCIP and like maybe what that's going to unlock, or if it's, even looking further in the future, like what today is, especially today in the bear market, what today is getting you really excited and looking towards like specific milestones in the future?
Yeah, I think it's kind of what I mentioned before, but I think like we're reaching a state where blockchains are actually useful for institutions, where that's always kind of been the narrative, like, oh, institutions are coming. But sometimes in the context, like they're going to buy our bags. I think it's more so they're actually going to use the technology, and they're going to issue more and more assets on chain. PayPal just launched a stablecoin. We saw the Swift experiment with all these different banks exploring using blockchains. I think that there's kind of been a shift where institutions want to issue tokenized assets. Like Larry Fink of BlackRock is talking all about tokenized assets. I think there was a report by EY or somebody about 93% of institutional investors see tokenization as the future of how the financial system will work. So it feels like we're reaching that point where crypto isn't just going to be about gambling on these different coins, anticipating maybe it'll be useful in the future, but we're starting to actually see movement from institutions tokenizing their assets, putting them on chain, and being able to use blockchains as an actual settlement layer for potentially trillions of dollars in financial assets flowing across these different networks and using smart contracts and a lot of the tooling that's already been built out for them. So to me, that seems like the major catalyst since retail kind of got wrecked by everything that's happened over the past year. Funds basically got wrecked as well. But institutions are more interested than ever than I've seen it. Like not just the Bitcoin ETF, spot ETF potential, but just actually using the technology itself. So I kind of see in the future that the same way where we can't really imagine what the world would be like without the internet. It's so ingrained into how society works and what we do on a daily basis. it'll be the same thing with blockchains where either somebody's using a blockchain directly, like they hold their own private key and they're using gaming applications or they're using decentralized social media or whatever, or the institutions that they already rely upon and use, they're using blockchains on the back end to offer new products to their consumers that are cheaper, that are more verifiable. They could prove they're not screwing you over because everything's being settled on a blockchain. That vision seems like it's happening. It's not completely realized yet, and it may take time with regulatory clarity. But I think that we're in a state where that vision is more clear than it's ever been, and I think that's super exciting to eventually see the whole financial system actually executing on chain on these different blockchains and everything becoming this interoperable internet of contracts all working with one another. So that's really what's taken my interest over like the past year as I've read through these different enterprise reports and seen how they've shifted their tone.
For sure. And it's hard not to give that answer when you literally have Swift like writing papers about Chainlink and CCIP. Like that's huge, man. That's literally unimaginable. Like when I entered crypto 2 years ago, but let alone when you entered crypto, or God, let's talk about like when Vitalik entered crypto. And so I think you're totally right. And if you'll indulge me for one moment, when I entered crypto, like part of it, the main reason that got interested and stuck around was not for like any of this crazy DeFi stuff or VE tokens or like perpetuals or any of that stuff. It was at Anheuser-Busch. I was the cash manager for almost 2 years. No, for over 2 years. And they like messing with actual money and large amounts of money is terrible. Like it really is true that all of these banks are on mainframe systems from the 70s and it's so slow and not like this transparency we talk about is a problem for the world's second largest consumer product goods company in the world. And like, man, I have stories to tell you about like what it's actually like to do a wire transfer of over $1 billion. Like, it's crazy. It doesn't make any sense. Like, they literally tell you it'll settle in 6 to 7 hours, and we don't know where the money is in the meantime. It's at some correspondence banks. It's over here. Like, we don't know. Like, stop calling us. And so, like, what I am like really excited about for crypto and for Chainlink, but especially after having this conversation, is like something that we don't talk about ever. And I think it's because almost no one in this industry has real experience in international business. But like half of my job was just figuring out how to get extra cash from US to UK, or like, we have like production problems in Belgium. We need to just like get a bunch of extra money there in order to like fix something. Like, how do we route that from South Africa? Or, like crazy just money problems that like most people don't even realize are like entire jobs and industries. And so like when I see crypto, I think like, oh my God, if Anheuser-Busch could use CCIP to plug in with Swift on the European side with their European banks, and then again plug in with using CCIP with Swift on the American side with the American banks, like the actual job of cash management becomes so much easier because you can actually manage your own cash. And so like what I'm excited about is like everything that we've talked about, everything that's already out there in crypto Twitter. But like what I'm really, really excited about is like for finance managers and like real business people to understand that this isn't just like some pie in the sky hippie stuff that is about like decentralization and governments and all this stuff, but it's about technology that is better than the old way we were doing things.
Yeah, I think you put it well there. It's I think a lot of people don't realize how broken the financial system is, or like they don't interact with it. They use fintech, which is kind of like a band-aid solution on kind of a broken system. Realistically, like when you make a transaction with PayPal or Visa, it's not settled. Like that's just like the authorization. It's settled like days later. Like we still do T+2 security settlement. Like the system is just pretty archaic and most people don't see it. They just see higher fees in worse products, basically. And so like tokenization will probably be in the background, but those benefits will flow down to them just due to the nature of competition between different institutions and different enterprises competing with one another. And yeah, like you mentioned, just the internal efficiencies alone of moving your own money around is something that can't be ignored, and something I think a lot of people don't even think about. They think the financial system works in a different way than it really does in reality. So I think that's part of the reason crypto doesn't really get the full I don't know if respect's the right word, but just like they don't see what it like the utility is. It's because they don't see what the problem is in the first place. So the solution doesn't feel like it's needed, but it's inevitable anyways, and most people won't even know they're using crypto. In my opinion, it'll just be abstracted away, just like nobody knows what cloud server Netflix runs on, and they don't really give a shit either. They just want to watch their movies, right? So it's the same thing with moving money around. They just want to move the money. They don't care how it gets there. They just care how fast and how secure it is. So yeah, it's interesting to see how this will play out.
Man, I need to go back and pull out that line. I love that. That's so good that most people don't understand crypto because they don't even understand what the problem is. Like, I think that's spot on. And I think that like the opportunity for us is like to be here and to see it first. And then most critically to build it, right? Like that's what we're here to do. We're builders. And man, all I can say is like, I wish I saw it when you did, and I'm just so excited to be here with you now. So, CLG, thank you so much for such a great conversation. I'm so glad we were able to like go back to basics on what Oracle was, and then like bring us through to how it's about to change the world. Really appreciate the time and the conversation. So, thank you.
Absolutely. Thanks for having me on. It was a good conversation.
For sure. And before I let you go, ChainLinkGod on Twitter, easy to find you. But anything else that like people who enjoyed this conversation should look into or check out? Where would you send people?
Main thing, my Twitter, ChainLinkGod on Twitter, and I also have podcast, CLG podcast. Haven't done one in a little while, but that one's much more like Oracle focused. I assume your podcast isn't just Oracle focused, but if you're curious about oracles and how they work, then I ramble and I talk with my co-host about oracles as well, for people who are interested.
Well, okay, perfect, man. And I wouldn't call this an Oracle podcast or a ZK podcast or whatever. Call it an Ethereum podcast. And I just try to bring in people who, for whatever reason, believe so much in this space that they've been willing to, basically sacrifice our reputations and our like good standing in society in order to make this thing real. So thank you again. Please go check out ChainLinkGod on Twitter and all the amazing content he puts out. And man, I hope I see you soon.
Thanks.